and welcome to Conversations with Dr. Kohli. Today, we're talking about an old friend, icosapentaethyl, or IPE, and cardiovascular risk reduction. Now, we first learned about icosapentaethyl and cardiovascular risk reduction from the REDUCE-IT trial, which was published back in 2019. But there's been a lot of new and exciting research in the field with both EPA and IPE, and I want to catch you all up on that. So to that end, I'm delighted to welcome Dr. Preston Mason. Dr. Mason is the president and founder of Elucida Research and a lecturer in the cardiovascular division at my old stomping grounds, the Brigham and Women's Hospital in Boston, Massachusetts. Welcome, Preston. I'm so delighted to have you here.
Great. Thanks, Pyle. I'm looking forward to speaking with you about icosapentaethyl and EPA, and hopefully it can be of interest to your audience.
Well, let's dive right in, Preston, because I have a ton of questions, and I know there's been a lot of new research. So I want to start by talking about the interface of GLPs and icosapentaethyl, because nowadays it seems like everything's about the GLPs. And I know for myself as a clinician as well, if I get a patient who is a diabetic or is obese or has cardiovascular risk and has elevated triglycerides, I will tend to reach for the GLPs first because I'm trying to go upstream. I'm trying to treat the obesity, the diabetes, and the metabolic syndrome that's caused those elevated triglycerides. But there's a lot more to it than that, right? Because we know that IPE and GLPs have complementary mechanisms of action. So take me through some of your research, which I've been really interested to read about GLPs and IPE.
Great question. Yes, there's tremendous interest in the GLP-1 class. And of course, the interest goes beyond weight loss and into cardiovascular protection. And that's where IPE or icosapentaethyl becomes interesting because that's already well established as a treatment for high-risk patients with cardiovascular disease. So the question is, could GLP-1s replace icosapentaethyl, or do you need both? Or could they actually be complementary? Could they actually be even synergistic, where they contribute through complementary pathways? So we asked that question and presented this recently at the American College of Cardiology. And we showed that both EPA, which is the active form of icosapentaethyl, just as a reminder, icosapentaethyl is cleaved in the gut to form active EPA, which is taken into circulation, repackaged, and then delivered to tissues in a dose-dependent fashion. So the EPA we use to treat cells in the presence and absence of the GLP-1. And both separately reduce inflammation and improve the expression of what we call detoxifying proteins under conditions of inflammation. In this case, the stimulus was angiotensin II to replicate disease conditions. And what we found was they both improved and reduced inflammation under these conditions, but they actually had an enhanced effect on the expression of proteins specifically targeting detoxification. In fact, we did a broad analysis of protein expression. We measured hundreds of different proteins. And what was remarkable was that EPA and GLP-1 separately increased proteins, but when combined, there was over 40 unique proteins expressed only when in the combination. And when we delved into these proteins, they were specifically linked to mechanisms of reduced oxidative stress. So we call them antioxidant response elements. And so this was the first discovery that two therapies working in a similar high-risk population may actually have additive or even synergistic benefits because there's changes in protein expression only seen when they were combined.
Oh, I love that. And very eye-opening because to your point, maybe they're working by sort of different mechanisms, even though they're working with the same sort of biomarkers, which are the triglycerides. Certainly the plaque data is also very thought-provoking in that sense, because we know that GLPs and icosapentaethyl both modulate atherosclerotic plaque differently as well based on coronary CT angiogram. So for me, I guess the takeaway message as a clinician then becomes, I really want to try to use both cardiovascular risk reducing therapies together. Would you agree?
Oh, absolutely. So it's just funny how we think just because there's a new therapy, it means the previous proven therapies are no longer relevant, but that can't be further from the truth. No, the well-established benefit to REDUCE-IT and the literally more than a dozen subsequent trials from REDUCE-IT has really established icosapentaethyl as safe and effective in these patients.
Great. So let's shift gears and talk about lipoprotein A, because that's the other kid on the block.
Oh, I love to talk about that.
Everyone seems to be talking about, right? And LPA is hot right now, and we all want to
Right.
check it. We all want to do something about it. And we know that lipoprotein A is 6 times as atherogenic as LDL cholesterol. It's largely genetically determined, about 70 to 90%. And really how we're using it in 2025 is a biomarker of risk, as a target sign on someone to further reduce their LDL. But I'm curious, have you looked at any work between lipoprotein A and icosapentaethyl? Because we know that lipid-lowering therapies can affect LPA, they can affect cardiovascular risk from LPA. So what have you found here?
Yeah, we have done more than 2 years. We've been working in this area, specifically looking at how EPA affects the atherogenic of LP(a). And we have a paper that will be coming out very soon. So a lot of exciting developments. But let's back up. Most of the therapies, as you know, being developed are targeted reducing the synthesis of LP(a), which is fine, which is a very reasonable approach. And with time, we'll see if it's effective or not. But I started thinking, well, isn't there any way we can reduce its toxicity other than reducing its levels? And I thought, in particular, what is considered the most atherogenic component of LP(a) is the OXPL content, or the oxidized phospholipid content. In fact, LP(a) is a primary carrier of oxidized phospholipid in humans. And we all know that oxidized phospholipid is highly atherogenic. It can trigger foam cell formation, and it can trigger damage to the endothelium. So we thought, well, while we're waiting for all these trials, why don't we try something that could immediately start to blunt some of the atherogenic? And so we looked at EPA because it has very potent antioxidant activity. We had previously published work in various lipoproteins, ApoB-containing particles, including small dense LDL, and found that EPA was superior to natural antioxidants like vitamin E, vitamin C, and even Probucol when it comes to blunting oxidized phospholipid. So we thought, well, let's extend this to LP(a). So we were able to identify patients with high levels, and through a sophisticated approach, we enriched the LP(a), brought it to the laboratory, and began to systematically test EPA at different doses in the LP(a). So the first observation was really interesting. Our hypothesis is that the OXPL on the LP(a) will make it more vulnerable to oxidation. In other words, you're seeding the lipoprotein already with oxidation. So when you subject it to the typical risk factors like diabetes, like aging, like hypertension, you're only going to accelerate the oxidation process. And that's indeed what we saw. It oxidized twice as fast as normal LDL and even small dense LDL, which we know is especially vulnerable to oxidation.
Wow.
So that was the first major discovery, is that OXLP(a) is much more vulnerable to oxidation and subsequent foam cell formation, inflammation, et cetera. So that right there is a big clue as to why there's increased risk. So if we can blunt that, Pyle, what if we could do that now? We could begin to reduce the toxicity of this key risk factor before we even think about reducing its levels. And so that was the nature of our study recently at ACC, where we added EPA to LP(a) as well as to small dense LDL, LDL, and even VLDL. And we looked at rates of oxidation. And we saw across the board inhibition of oxidation with EPA, but it was disproportionately benefit in the LP(a), only because of its faster rate and higher susceptibility to oxidation. So for the first time, we may have a therapy that can blunt the pathogenicity of LP(a), and we don't have to wait years for it to come out. And as you know, when these trials do come out, they'll only be available, this drug, for very high-risk patients with very high LP(a). So the vast majority of those with elevated LP(a) will have to wait many, many years before they see any benefit or any treatment. So I'm especially excited about this as a new model for thinking about how to reduce the risk associated with LP(a).
I mean, that's fascinating. And as you're talking as a clinician, what's popping into my head is all my patients, my 20% of my patients that have an elevated LPA, and perhaps some of these other metabolic risk factors that, as you said, almost serve like a double whammy, would this type of an agent be a good intervention in those patients. So really provocative research and a really different way to think about reducing risk from LPA, not targeting the synthesis, but actually targeting some of the downstream effects. So for the clinicians out there, Preston, would you say that the take-home message is for your, diabetic obese patients with elevated triglycerides and elevated lipoprotein A, there's perhaps even more benefit to starting this medication?
Absolutely. So I'm not saying use it exclusively only on your patients with high Lp(a), but I'm just saying if your patient already is qualifying for icosapent ethyl, this is yet one more reason to do so. And I'm sorry, I have to tell you about what's coming up at ESC. We did additional studies where we then looked at the effects on vascular function. So we took Lp(a) in the absence of presence of EPA and exposed it to the vascular endothelial cells and to see if we could blunt some of the pro-atherogenic and pro-inflammatory effects of the Lp(a). And indeed we did. So we've now taken it from the isolated lipoprotein to the vasculature to do that translation into more relevant models of cardiovascular disease. And we'll be presenting that at ESC very soon.
Well, congratulations. I can't wait to see that. And I'm going to come back to EPA in a second because I do want to talk a little bit about diet and how we can enrich EPA in our own lives. But let's talk about LDL for a second, because, in the modern era with PCSK9 inhibitors, we drive people's LDL super low. So is there a benefit to still using an agent like icosapent ethyl when you already have achieved a super low LDL? Have you looked at that at all?
Yes, we actually did look at that. This is a sub-study from Reduce It, where we looked at the benefit of EPA, and we looked at patients who had LDL driven below 55, which is very aggressive, more European than even than Americans. And then we looked at the benefit in patients above 55 mg per deciliter, and the benefit was consistent. So there was still benefit with icosapent ethyl, even in patients with LDL below 55.
So really a parallel pathway of risk. You've got your LDL. We talked a little bit about the LPA pathway. We've talked about obesity and inflammation. Now we're starting to see in our mind all these parallel pathways of atherosclerotic risk.
We're really getting at residual risk with EPA. And as a scientist, this is really exciting because I've been studying, as you know, Pyle, the mechanism for almost 10 years of these omega-3 fatty acids and differentiating EPA from DHA and ALA and other omega-3 fatty acids, and finding that EPA and its metabolites, which is very important to note, have these broad multifactorial effects that may influence the natural history of cardiovascular disease at multiple points, not just modifying lipids, but early endothelial dysfunction, oxidized lipoproteins, inflammation, and ultimately resulting in reduced target organ damage and death. So I think along the continuum, unlike a lot of very highly focused agents, EPA may be working at multiple levels to reduce overall risk. And that's evident in all the, not only reduce it, but all the follow-up trials in patients, like in patients with a recent STEMI, there was a 40% relative risk reduction. So numbers need to treat down to like 10 or 11. So there's so much behind the EPA in terms of the science that's very exciting.
So, Preston, I have to ask you, because all my patients ask me, and I'm curious for myself as well. Americans have a very low EPA diet. We generally tend to have lower EPA levels. Should we be checking our EPA levels? And should I be taking over-the-counter fish oils to supplement more EPA in my diet, or how do I get more EPA? And what do you do? What do you recommend?
Well, you really hit a nerve because I get asked that a lot. And I get asked that so many times that I took my research team. We went to the local store and bought the most popular dietary supplements of fish oil. And we brought it to the lab. We literally cut open the capsules, poured it out, and we did very sophisticated analyses of the content, so the total fatty acid content. We also looked at the levels of oxidation. These have multiple double bonds, these omega-3 fatty acids. So if they're not very carefully handled, they very quickly get oxidized and go from something that's protective to actually something that's actually pro-atherogenic, because in the oxidized state, it's very toxic, actually. So sure enough, when we looked at the dietary supplements based on sales, and we looked at the content, a couple things emerged. One is the actual EPA content is very small, usually less than 20% of the overall oil. So just think of that, 80% of that oil with lots of calories is not even EPA or DH or even DHA. So that's one clear problem. So you might ask, what are those other oils?
Yeah, I was thinking that.
Would you believe a third of them are saturated fats?
Oh my goodness.
So you're not only getting all this other oil with lots of calories, but roughly a third of it is saturated fat, which is the worst thing you want as a patient, cardiovascular risk patient. And then the other one, we saw literally dozens of different fatty acid species. I had never seen some of these before. So various saturated, unsaturated forms. The point being, your patient is taking all kinds of stuff that is not intended beyond the EPA and DHA. But it doesn't stop there. I got worse news. When we looked at the quality of the EPA, and that is the integrity, most of it was damaged from oxidation.
Oh my.
So we looked into the manufacturing and found out it's like industrial scale manufacturing, where they take the small fish off the coasts of South America, crush them, and squeeze out the oil under non-controlled conditions. So exposed to oxygen, exposed to air, exposed to heat, and literally put them into the capsules without any purification process.
Wow.
So you can imagine, like we in the lab, if we take pure EPA from the bottle and put it even on the lab bench at room temperature, it will undergo oxidation within an hour or two. So imagine being out there for days, perhaps, these being in storage without any control. So they're basically useless by the time they get into those capsules. So I hope that maybe more than you wanted to hear, but these are not a good idea to take.
I mean, I know I've been telling my patients to stop them because of the antiplatelet effects and as well as the proarrhythmic effects that can cause AFib. And we live here in Denver at higher altitude. But that is really, really eye-opening for me to hear so much saturated fat in there. And of course, the EPA getting oxidized, which means you may actually be doing even more harm than good. So certainly a great take-home message for our clinicians. Preston, I want to ask you, is there anything coming down the pipeline? You talked to me about your research at ESC. Is there anything else we ought to be looking out for with respect to icosapentaethyl EPA and what's cooking on the horizon?
Okay. So we're doubling down on all this research, particularly the LP-LA, given I think it's going to be a major risk that will be, for the most part, untreated for many years to come. Again, to reiterate, these wonderful therapies that are being developed, if they prove to be successful, will be highly limited, as most are, to those patients who are at higher risk and very high LP-LA. But we know that and you may or may not agree, but my interpretation of the data is that the risk is linear. So anything above 50 mg, that is arbitrary, but the risk just goes up and up. So you're not safe when you get it below 100. Point being, we need to consider things we can use now and today safely and effectively and that are proven. So if icosapentaethyl could be a model for that, of other ways we can think about more immediately reducing the risk, I think that's an exciting area. And also, I think with the excitement over GLP-1, I think it's terrific, but I sometimes think we need to keep perspective that there are other proven therapies out there, and these are not the cure-all for everything, and that it's not as if they cover all the mechanisms of disease. So thinking about GLP-1 in the context of other proven therapies is very important. Just like we always had statins, we need to also consider icosapentaethyl for those high-risk patients.
I'm so glad you made that point, because I see clinicians all the time just starting the GLP-1 and thinking that it's going to fix the LDL, it's going to fix the LPA, it's going to fix everything. And to your point, these are, parallel pathways of risk. And so one medication doesn't necessarily reduce their risk entirely. So Preston, I want to thank you. I've learned so much in this conversation that I know I'm going to take back to my patients. And it's been a bit of a whirlwind to see, icosapentaethyl with GLPs, to see how it interacts with the LPA pathway. And of course, to hear a little bit about over-the-counter fish oils, which I know so many people reach for. And, Costco has a big batch of it. Maybe I'll write a letter to them and let them know to start continuing that. But thank you so much for your expertise. I so appreciate your time. And I'm looking forward to continuing this conversation with you again in the future. And thank you all for tuning in to Conversations with Dr. Kohli. Until next time.